Okay, I have something to show you. Watch this. Take a triangle, and we're going to call the vertices A, B, and C. Okay, now if this is the angle A, then this corresponding side is going to be small a, this corresponding side would be little c, and this corresponding side is going to be little b, which I'm not going to label just yet. And if I put the vertical height in, this will be at 90 degrees because it's vertical, and we'll call that h to represent that height. Now, we're all familiar with this rule, the sine theta is equal to the opposite divided by the hypotenuse. Okay, now I'm going to use that rule a couple of times. Starting with this ratio, we know that the sine of this angle is equal to the opposite. Now the opposite in this case is h divided by the hypotenuse, which is small c. Okay. Now if I were to rearrange this, I could say that c times sine A is equal to the vertical height. Alright. I'm going to use that rule a second time now. Watch this. If I use it for this angle, I've got sine C is equal to the opposite is h again, divided by the hypotenuse of this triangle, which is small a. Alright. By rearranging this equation, I could say that h is equal to a times sine c. And so we now have two equations, both as h as the subject. If I do a direct substitution, substituting a times sine c and put that here, what we can conclude then is that c times sine A is equal to a times sine c. Alright? Now, I could rearrange this a little bit and say, alright, I'm going to put all the a's to one side and all the c's to another side. So if I move this a down, I get sine A over A is equal to, move the c down here, and I get sine C over C. And this is what we call the sine rule. This is the sine rule, okay? And there are a few versions to the sine rule. We could say that if I were to invert this formula, it would be A over sine A is equal to C over sine C, okay? And last thing I want to show you is I use the vertical height going this way, but if I used BC as the base of the triangle, then the vertical height would have gone this way. And h would be over here. And instead of using these two vertices, I would have used this one and say this one. Okay? And so all of this working out would still be valid, but it would be in terms of B's and C's rather than A's and C's. And so we can conclude that the ratio is also true for sine B over B, and over on this side it would be B over sine B. And that's the sine rule. Good luck with your questions.